100,000 tons of steel sits locked in place, surrounded by concrete walls taller than buildings. For years, it doesn't move an inch. Then one day, with a single command, millions of gallons of water begin to surge in. Slowly, almost like it's waking up, this massive warship starts to rise. Not pushed, not lifted, just floating for the very first time. That moment changes everything, because what you're looking at isn't just a ship. It's one of the most powerful weapon systems ever built. And here's the crazy part. Most people have no idea how something this massive actually goes from dry land to dominating the open ocean. Today, you're going to step inside that process. You're going to see how these floating cities are born, how they're launched, and why they remain unmatched anywhere in the world. From the massive dry docks in Virginia to the cutting-edge systems that launch fighter jets into the sky, this is the full story behind America's most powerful aircraft carriers. And before we go deeper, I want to know something from you. When you think about something this massive being built by human hands, what's the first word that comes to your mind? Drop it in the comments. I'm curious what you think. It all begins in a place most people will never see in person. Along the James River in Virginia, there's a shipyard that doesn't just build ships, it builds giants. This is where the largest and most advanced aircraft carriers on Earth come to life. Picture a construction site so massive it looks unreal. Steel structures rising higher than buildings, cranes moving pieces heavier than entire houses, and thousands of workers moving with precision like a living machine. This isn't just any shipyard. It's the only place in the United States capable of building nuclear-powered aircraft carriers. And the heart of it all is something called a graving dock. Imagine a gigantic concrete basin, longer than multiple football fields lined up end to end, and wide enough to swallow entire city blocks. This is where the carrier is built from the ground up. Now here's something most people get wrong. You might think a ship this big is assembled like Lego pieces, built in sections and then connected later. That's true for many ships, but not here. Aircraft carriers are built as one continuous structure. Every single part is planned, measured, and installed with insane precision from the very beginning.
You're talking about millions of parts, miles of wiring, entire rooms, corridors, control centers, and living quarters. All of it built while the ship is sitting on massive support structures called keel blocks. These blocks don't look impressive at first glance, but they carry the entire weight of the ship for years. And we're not talking about a small load. This is the weight of hundreds of fully loaded passenger planes combined, resting on these supports while thousands of workers slowly bring the ship to life. Think about that for a second. For years, this enormous war machine just sits there, not moving, while everything inside it is built piece by piece. If that doesn't blow your mind, I don't know what will. And let me ask you this. Would you trust something built at this scale to work perfectly the first time it touches water? Be honest. Drop yes or no in the comments. Because here's where things start to get even more intense. After years of construction, testing, wiring, welding, and assembling, the moment finally arrives. The day when this giant will meet water for the first time. But it's not dramatic like you see in movies. There's no sudden splash or giant drop into the ocean. Instead, it's one of the most carefully controlled engineering processes you'll ever witness. The flooding begins slowly. Water starts entering the dry dock, rising inch by inch. At first, it barely looks like anything is happening, but engineers are watching everything, every level, every pressure point, every structural response. This isn't just about filling a space with water, it's about controlling millions of gallons with absolute precision. As the water reaches the base of the ship, something incredible starts to happen. Even though the carrier is still resting on its supports, buoyancy begins to take effect. The ship starts to feel the water, and this is where physics takes over. The same force that keeps a small boat afloat now begins working on a vessel that weighs more than an entire city's worth of buildings combined. Slowly, gently, the carrier begins to shift its weight. More water flows in, more pressure builds, and then, at a certain point, something magical happens. For the first time ever, the ship is no longer fully supported by the blocks beneath it. It starts to float. Think about that moment. Years of work, thousands of people, billions of dollars, all leading to this exact second. And it either works or it doesn't. That's why everything is tested again and again before this happens. Because once it floats, there's no going back. I want you to imagine being there, watching something that big rise out of nothing but water. Would that feel exciting or terrifying? Let me know what you think. As the dock fills completely, you're now looking at over 100 million gallons of water surrounding the ship. At this point, the carrier is fully afloat. But even now, the process isn't over. Because floating is one thing, moving is another. Now comes one of the most delicate operations in the entire process, guiding this massive floating structure out of the dock. You can't rush it. You can't force it. Everything has to be done with precision down to inches. Specialized tugboats move into position. Pilots and engineers coordinate every movement. The ship is slowly guided through the narrow exit of the dock. And remember, this isn't a small vessel that can easily turn or adjust. This is a floating city. Every movement takes time. Every adjustment must be perfect. One wrong move could cause damage worth millions. So everything is slow, controlled, intentional. And when the carrier finally leaves the dock and enters open water for the first time, that's when it truly begins its transformation. From construction project to naval vessel. At this point, the ship still isn't ready for combat, not even close. There are still months, sometimes years of work left. Systems need to be tested. Crews need to be trained. Every piece of technology must prove it can perform under real-world conditions. And this is where things get even more interesting. Because modern aircraft carriers aren't just big ships, they're packed with some of the most advanced technology ever created. One of the biggest changes in recent years is how aircraft are launched from the deck. For decades, carriers used steam-powered catapults. These systems worked, but they had limitations. They were powerful, but also rough on both aircraft and pilots. Now, things have changed. Today's carriers use electromagnetic launch systems. Instead of steam, they use advanced electrical systems to accelerate aircraft down the deck. The difference is massive. Launches are smoother, more controlled, less stress on the aircraft, less strain on pilots. And here's the big advantage: flexibility. These systems can launch a wide range of aircraft, from heavy fighter jets to lighter drones, all with precision. And because they reset faster than older systems, carriers can launch more aircraft in less time. That means more power, more efficiency, and faster response during critical moments. But let's be real for a second. New technology isn't perfect right away. Early versions of these systems faced challenges, reliability issues, performance limits, unexpected problems. And this is where something important stands out. Instead of rushing these systems into full use, engineers and the Navy kept testing, improving, and refining them. Because when you're dealing with something this critical, good enough isn't acceptable. It has to be right. And over time, improvements have made these systems more reliable and effective.
That's the difference between something that looks good on paper and something that works when it matters most. Now think about this. All of this technology, all of this engineering, all of this complexity, none of it exists without people. Thousands of workers are involved in building a single aircraft carrier. Welders, engineers, electricians, designers, technicians. Each one responsible for a specific part of something much bigger than themselves. And many of them come from families who've been doing this work for generations. Skills passed down over decades. Experience built over years. Pride in building something that represents national strength. Because at the end of the day, this isn't just about building a ship. It's about building something that will carry thousands of people into real-world missions. And that responsibility changes everything. Let me ask you something. If you were part of a team building something this important, would you feel pressure or pride? Or both? Tell me in the comments. Now zoom out for a second. What does all of this actually mean on a global level? When an aircraft carrier enters the ocean, it doesn't just become another ship. It becomes a signal, a message to allies, a warning to adversaries. These carriers can operate anywhere in the world without needing permission from other countries. They bring their own air force, their own defenses, their own support systems. They can respond to crises, support operations, and project power across thousands of miles. And they don't operate alone. Each carrier is part of a larger strike group, including destroyers, submarines, and support vessels. Together, they form one of the most powerful military forces on the planet. And here's the key point. The ability to build, launch, and operate these carriers is something very few countries can even attempt. That's what makes them so significant. Now, looking ahead, the future of these carriers is already being shaped. New ships are being built with even more advanced systems, better efficiency, greater flexibility. And one of the smartest decisions in their design is something most people don't think about. They're built with extra capacity. That means future technologies, things that don't even exist yet, can be added later. Whether it's advanced weapons, new radar systems, or completely new capabilities, these ships are designed to evolve. So what you're seeing today isn't the final version. It's just the beginning. And that brings us back to where we started. A massive steel structure sitting still for years, suddenly rising into water for the first time. That moment isn't just about physics or engineering. It's about transformation. From idea to reality. From steel to power. From construction to capability. And every time it happens, it tells the world something very clear. That innovation, effort, and precision still matter. Before you go, I want to ask you one final thing. After seeing how these carriers are built and launched, do you think anything else in the world comes close to this level of engineering? Drop your answer below. I read a lot of your comments, and I want to hear your perspective. If you enjoyed this and want more deep dives into naval power, technology, and the stories behind these incredible machines, make sure you're subscribed, because the next video is going even deeper. We're going inside what life is actually like on one of these carriers at sea, the routines, the challenges, and what it really takes to operate a floating city in the middle of the ocean. Until then, keep your curiosity sharp.